This video is on graphing radical functions. I'm going to look at the vocabulary of radical functions at the moment. A radical function is a function that can be written in the form f of x equals the nth root of x minus h plus k, where a is not equal to 0. The a value would be the number in front, because if this value is 0, then it would just be a linear function. It would be a horizontal line. The n, which is your index, also cannot be smaller than 2. You cannot have what's called a 1th root. This is an nth root because any number can be in here as long as it's 2 or greater. So for any values, any even values of n, the domain and range of a radical function is the real numbers confined by h and k. So we have to know what our h and k values are to determine our domain and range. But for odd values of n, the domain and range of a radical function is the real numbers from negative infinity to positive infinity. So they are not confined by h and k. So let's look at this first example of just determining what a, h, and k are. Now a will actually tell you two different things. A will tell you if it's a reflection, and a will tell you if it's a dilation. So we actually need to understand, is a positive or negative, and then what is the absolute value of a. So the first thing I'm going to write out is a is equal to a positive value. So I'm not going to put a number, I'm just going to put a positive. We also know that a is equal to that value, the absolute value of this is 3. Then we determine our h value and our k value. The h is inside with the x. We want to know what value would make this inside of the radical, the radicand, a value of 0. Notice that it says x minus the h, and this says x minus the 2. That means that the h value is actually equal to a positive 2. And we know that 2 minus 2 gives us 0, so that's why h will be the value of 2. We also determine the k value, which is what's added or subtracted to the problem, not multiplied. So our k value is a positive 6 because we're adding 6. Now, we've determined this so that we have our confined h and k. We know that h will be part of our domain and k will be part of our range, because domain is with the x values and range is with the y values. Now, because the a is positive, this will actually help us to know our range. In this course, when you're graphing radical functions, we are always going to have it graphed going towards the right-hand side. So our domain of this problem will actually start at our value of 2. We're going to have a 2. We're going to have a closed bracket because what we're doing is we have a minimum of 2, but it's going to keep going towards the right because we know that we cannot have the square root of a negative value. So it's going to go to the positive infinity, which we'll have an open bracket for because it does not actually stop. Our range, just like with quadratics, comes from our a value being positive or negative and what our k value is. So because our a value is positive, that tells us that our graph is going to be going up forever, not down, because this would not be a reflection. This is going to keep going up. So our range, we're not going to be able to stop our range, so it's going to have a maximum of positive infinity because it never actually ends. So our minimum value is confined by the k, which is 6. We're going to have a closed bracket because it actually does stop at the 6. So our domain and range for a square root, 4th root, 6th root, anything with an even root will be confined by your h and your k. Whatever your h and k are going to be in your domain and range. But again, for odd values of n, like a cubed root, the domain and range will automatically be negative infinity to positive infinity. It will not change. But we can still determine what our a, h, and k are just so we can get that practice. So our a value, it says f of x is equal to 5 times the cubed root of x plus 4, then minus 2. So the a value we want to know is a positive or negative. And this is a positive 5, so we're going to put positive. But we also want to know the actual value of this. So the absolute value of 5 is 5. So if I combine these two, this is a positive and a 5. That's what this is. It's a positive 5. The h value, again, is what value would make the radicand equal to 0. We know that x plus 4 really needs to say x minus something. So it needs to say x minus what would give you that positive 4. So x minus a negative 4 would give us x plus 4. And we know that negative 4 plus 4 will give us the 0. So that's how we know h is negative 4. Our k value is, again, what is added or subtracted to the outside, not multiplied. So our k value, it says plus our k value. Well, it's going to be plus a negative 2 to get that minus 2 aspect. So we just found those because we need that practice of finding a, h, and k. Now again, because the in value, our index is 3, which is an odd value, our domain is automatically going to be from negative infinity to positive infinity, and our range will be the same. It will be from negative infinity to positive infinity, and that will happen with any cubed, fifth, seventh, ninth root, any odd root. We'll get these. Now, just as a quick thing for families of radical functions, we have square roots, but then we have any type of radical. So this is any type of root. We have to follow the same information because it follows the same pattern. We're going to be focusing more on square roots, but you can follow these transformations for any type of radical. So our parent function is when there is no a, or your a value is 1, your h value is 0, and your k value is 0, because we want it to start at 0, 0, and not be dilated. So parent function for a square root is just y equals the square root of x. For any other radical, it's y equals the nth root of x, so whatever that root is. The reason we figure out the a value is positive or negative, the a value is a number, the h value, and the k value, is because we need to know what that does to our transformations. So when you have a reflection in the x-axis, you have a negative in the front. Your a value is negative. That's why we want to know is it a is positive or negative, because the negative makes it a reflection in the x-axis. Then we determine the value of a, the absolute value, the positive number, to tell if it's what the dilation is. So if your a value is larger than 1, like 1.1, 1.2, 5, 18, this will become a vertical stretch. If you have your a value is smaller than 1, but again, it still has to be bigger than 0 because we want the positive aspect of that number, then it will be a vertical compress because it's going to shrink. So again, it comes from the value of the a, which is why we separate the two parts of the a. The translations come from the h and the k. It will translate horizontally, which is left and right, by the h value. So just remember, the h value is basically the opposite of what you see because we want to make this radicand equal to 0. We want to know what will make that equal to 0. You will also translate vertically, so up and down, by the k value. So you're going to keep whatever that k value is, whatever you've added or subtracted. Even if the k value is added or subtracted to the front of the problem, you need to make sure you understand which one is your h, which one's your k, and which value is your a. And these are the vocabularies and the transformations of radical functions.